Hello and welcome LA Blockchain Summit. Today, we will have a workshop on how to create your own module with the Cosmos SDK. Maybe you have seen my previous talk as a general introduction into what is Cosmos, how does Cosmos work, what are modules on the Cosmos ecosystem, and how you can actually create a project and participate in the upcoming Hackathon 6, where we will have various challenges where you can learn and create your own software and eventually get rewarded with great prizes. The Hackathon 6 has prizes at around 1 million USD that various participants can receive. So today we thought I can give you a workshop about one of the upcoming tutorials, how you create a new blockchain and a new module with Starport. What we will go through today is something that we call a token factory. So maybe you are already familiar with a few concepts of the Cosmos SDK, what modules are and how they work and how you can integrate other modules as well. So the Cosmos SDK is oft described as building modules together and create blockchains like building with Lego blocks. And today we will create one module, but you can also check out other official Cosmos SDK modules. So let me quickly show you how a regular module looks like and what the official modules are that you can use. Let me share my screen. Maybe you've already had a look at this repository. To start building your own blockchain or module, you want to get to know the Cosmos SDK repository as good as you can. You will find a lot of help functions when you're developing, but also documentation or inspiration from the tests or from written comments in the code. What I recommend you to look at is especially the X directory that you see in this repository. This is where modules are written and listed. And in here, you will find all the official modules from the Cosmos SDK, which is authentication with an extra, where you can create other accounts that you can allow to do certain operations on the blockchain. We have a very important module, which is the bank module, and we will be using this today. The bank module is responsible for token issuance or also token transfers. We have a lot of other very important modules, which are, for example, the distribution, where you can define how tokens get distributed on your blockchain. We have Genesis util function, so you need to have a start for your blockchain. Maybe you want to upgrade your blockchain at some point. We have a governance module on which you can allow your blockchain to create on-governance proposals. So all stakeholders can vote on the future of the blockchain, maybe which feature to include in the future, or also find agreements on various other constants that your blockchain might be working with. You can learn more about minting, about NFT, different parameters that you have in your application, about slashing and staking and how to upgrade a blockchain. But without further ado, let's jump into this tutorial. So first of all, I am currently on a deploy website because this tutorial is not yet live on the website. So feel free to regularly, actually on the new website, docs.starport.com, you will, on the new documentation side, you will find the developer tutorials on the left-hand side. Feel free to go through them, and especially the introduction, install Starport and minimum hello world to get suited for this tutorial. So if you're watching a video of this, or if you want to check it out later, please first go through those first 3 items before you go into more advanced module creation. But We are here to learn, so you don't need to understand everything. For everyone that does, the better, but else just follow me along and while I'm building a blockchain with a module, and you will understand a lot more about the Cosmos SDK. So today we will look into the token factory module. So this is an advanced module from my perspective in the Cosmos system, and I think others would agree. This is quite more complex than we had before with the Hello World or with the blog tutorial, but it goes along maybe with name service scavenge or the DEX tutorial that we provide here. And in this tutorial, you will build a token factory module. The token factory is used to create native denums on your blockchain. First of all, a bit of context is that unique digital assets are key promises that blockchains deliver. We eventually have scarcity on the web. This was impossible to imagine before the emergence of blockchain, and now it's a huge scene that is growing. For example, on Ethereum, the standard of an ERC20 token has seen a big popularity in the crypto scene. By creating native daemons on your blockchain, you learn skills to manage one of the core benefits of blockchain technology. We'll learn to create a module. We will delete one function of the CRUD operation that Starport gives us. So you will learn the ins and outs of this create, read, update, and delete operations. We will talk a bit more about denums, what are denums on the Cosmos SDK and how to work with them, how to identify them. We will work with the client, with types, keepers, expected keepers, and handlers to apply the token factory application logic. And all these items that you will see are actually what makes up a module. So these are all part of a module. Touch each of those a little bit so you see and understand how modules in the Cosmos SDK work, how you can create your own, maybe inspired by this tutorial. And one side note, the code in this tutorial and workshop is specifically written for this learning experience and is only intended for educational purposes. The code of this tutorial, of this workshop, is not intended to be used in production in any form. Please make your own research. Please think of all the edge cases that might come up using such a module, and please make sure you have the legals right when starting such a module. So about the module design that we are building, the Token Factory module allows you to create native denums on your blockchain. A denum is the name of a token that can be used for all purposes with Starport and the Cosmos ecosystem. And we can learn a little bit more about denums. Denum stands for the denomination, and we differentiate between kind of native denums and IBC denums in our use case and in our ecosystem. Because with IBC, you can send your tokens to any other blockchain. You can create a new channel and send tokens over to another blockchain. Those will create a new token on the other blockchain, which denum start with IBC / a hash that describes the root of that token coming from and how it traveled in the ecosystem. Today, we will be looking at native denums. So they don't start with IBC. They are similar to what you might have seen as UAtom on the Cosmos Hub. So they are created as if a blockchain would be started with those tokens on your blockchain. Learn more in the documentation of Starport about how denums work with IBC, how they are encoded, how to parse them. Please check out docs.starport.com if you want to learn more about what denums are and what role they play in the Cosmos ecosystem. There's also good documentation on how coins and denums work together in the code and in the concept. So please feel free to read the ADR 024 about coin metadata. So let's describe how a denum, what parameters a denum has in our token factory. A denum in this module always has an owner. The owner is allowed to issue new tokens, change the Denum's name, or transfer the ownership to a different account. The Denum consists of a name, which is and a property, which is the ticker. The exponential of the Denum is held in the precision. So below here you find a proto definition of the Denum. And on here you see all these items, right? It has a Denum and it has a ticker, both strings. It has a description, so you can describe what the token and Denum does and eventually what purpose it has, and a URL where you could read up about more information about this Denum. It has a supply and a max supply. So the supply is what's currently in circulation. Max supply is what only allowed to be in total circulation. There's also a Boolean can change max supply. This can only be set to false once. Once you set this to false, so you cannot change the max supply anymore, it will stay this way and have a fixed and locked max supply. Then we also have the owner property, which is associated with an account who can control this Denum. We need to program a couple of functions. So we need to program how to issue a new Denum, how to change the ownership, and how to track all of the tokens with these daemons that are in existence. So let's get started. We scaffold a new token factory blockchain with the --no module flag because we want to add our own module afterwards with our own dependencies. So let's get started. I create a new working directory for this workflow, and then I just jump into starport, scaffold, chain. So we scaffold a new blockchain, and we will look into this in a bit. We scaffold it with github.com/our example user. This is an existing user, but it's not related to us. This is our example user. So for me, in the real world, I would probably exchange with a username. But in our example, we use the Cosmos now. And we create a module, a new repository, and a new code base in directory with token factory. And in this directory, our blockchain will be launched. We specify no module because in the next step, we are actually adding a module with dependencies. If you're not new in the programming world, maybe this scaffolding functionality rings a bell when you've used things like Ruby on Rails or React or any other framework that lets you create a new code base and provides a lot of bootstrapping for you. So let's look into what Starport provided us here. I'm opening my VS Code. And on the left-hand side, you will find the directory structure of our new blockchain. On the right-hand side, we will look into the code. In here, you find the directories for the application. This is where all the modules that you use are wired together. So in here, you will find modules referred to that we just looked at in the GitHub repository, such as out, the bank, capability, crisis distribution, and others. And they are all wired together into the application here. Command, you would define your command line interface for your blockchain. In the docs, you can read more about Starport, and a bit is already created for your blockchain. In the Vue repository, we won't use this today. In here, you have a whole front end already at your service that you can manipulate and use for first scaffolding or eventually for your app. So from here, let's cd into, I already did that. Now it's time to scaffold our module, which is also called Token Factory, but this time it has a dependency on account and bank. So these two modules is what our module will be using. There will be a direct connection between our module and the account module, as well as the bank module. And this deb dependency flag, it describes that we want to use these two modules in our application. This has created a new module. So now we see with a new module, the X directory also here. This is where the module lives. And here we have the client, the keeper, types, as well as the J and module.co. And we will look into each of those directories with its file in a bit. So first, we scaffold a CRUD operation for Denum in the token factory. We use a starport map for the data stored as key value pairs that define our format. So let's copy this, and it will create a very similar structure, or it will create this structure that we've just identified above on here. So let me use this command, and we'll observe what it does. If we now go into our proto directory and the token factory, we will see a Denum that is described just as we've just talked about before. It has all the parameters, and this is due to, in our call, we have defined to map a new Denum with a description, which is a string, a ticker, precision, etc. And this describes our existing structure here. Before we continue, this is a good point. After scaffolding, it's always a good idea to use Git and add all the new created changes to our repository to the existing GitHub repository. Starport creates a GitHub repository for you, and with a first commit, and we will now stack on top. And our commit is add token factory module and Denum map. And as you can see here, we've already created a lot of new files and changed a lot of files. This is where Starport helps us a lot, and we don't have to do it manually with using the Starport command. So we'll just take advantage of that and continue moving on. Denums should be created, can be updated, be read, but they shouldn't be deleted. So we will take care of this, and we will explore how to delete something from the CRUD type scaffolding, and so these are a lot of changes. So I will try to make it a bit quicker. I hope you can follow along. But the purpose of this is that you see what's necessary in order to do to change something coming from Starport as a default. So I hope I don't lose you here, but yeah, it's a few changes, so just follow along and you should be fine. So first we go into our token factory tx.proto, and in here we will see a message that's delete Denum, and we don't want this, so we remove this line on here, and we also remove the according messages from the profile. Now it's time to look into the client. So we navigate to token x into our x directory, token factory, and client. And in here, we find a xdenum test.go file. And it's also testing our delete denum. So this is a function and a test we don't need anymore. Just get rid of this. Also in the CLI txdenum.go file, we also have a function that describes deletion of denums. We don't want this function anymore. We can just delete it straight away. And then in the tx.go file, we have a wrapper that adds the command, so we also need to get rid of this. So this is for the client. Let's go into the keeper. In the keeper directory, we also have a few files that refer to have logic for deleting a denum. So we first go into the keeper, into the test.go file, and do the same thing as before. We also delete the deletion test. And this is the remove denum function. All right. Next, in the keeper/denum file, we also have the remove denum function that we don't want to maintain. Next step is in the keeper, in the message server denum test, we remove the test denum message function. Gone it is. And lastly, in the message server denum.go file, we also remove the delete denum function. There we go. Next, we look into the types directory. It also defines function and validation that describes the format of the blockchain data. In here, we have to remove a bit of functionality. So let's first look into the codec. We have any reference to deleting a denum that we don't want to keep. And in here, we are registering the message delete, the interface, and we don't want that anymore. So we delete those two lines, and then we can go into the message denum test, because we want your test to also function afterwards, and we won't have deleting denums anymore. And lastly, in the message.daemon.go file, remove message delete denum function. And all the functions that are building on top of it. This looks good. Next thing is we look into the handler. In the handler, we will find a switch statement. Like this. In here, you see the switch statement. And this iterates over different commands that are coming into our application. And on here, we also want to remove the case for message delete denum, as this is not a message anymore. Great. This fulfills our duty for removing the delete functionality. And let's make sure we can, we save our state, we do git add, we commit remove the delete denum functionality. Great. Now, after scaffolding and exploring a bit of the code base, we have looked into the keeper, into the types, into the handler. We looked into the CLI and already touched so many files. And I hope that you got a first impression of how such a project looks like. Let's jump into application logic. So on here, we will finally start building and start creating our own module. First things first is we look into our proto file. So this describes that we are going to work with in our application. So we first go into the tx.proto file. For the message create Denum, we want to remove the supply line, and we change the reference of the can change max supply. All right, removing the supply from here, from the tx.proto for creating a Denum, because a Denum is always bootstrapped with no supply, but it has a max supply, and the supply can be added by the owner. But we don't already start with an existing supply. Oh, I was actually in the wrong. For creating Denum, we want to change this. And so let's reverse this. Okay, here we go. This is the right one. Next, we look into message update Denum. We are removing the ticker, the precision, and the supply. And we should end up with owner, Denum, description, URL, max supply. Should I increase the font size a bit? And can change supply. So let's update really quickly here. We have only 6 parameters left. Very good. Next is we look into our client. The application logic, we need to look into our client, into the tx Denum file. And we need to reflect the changes that we've just made. So for the command create Denum message, we changed the number of args from 7 to 8. From 8 to 7. We remove reference to the supply argument. We reorder the args also accordingly, and change the usage descriptions. So that we don't sit here too long, I will just copy and paste this function and use it as it's recommended here. You can at home do the same and then kind of watch the result, or if you're challenging yourself, you can implement them on your own, and this is how you would learn the most actually. Let's also look at the update daemon. You might see errors here, but this is because we haven't implemented all the changes yet. We also need to change a number of args. We remove references that we just deleted for supply, precision, and ticker, reordering the arguments, and change the usage description. So let's also make the same trick here. We copy and paste the changes. And on here, we can see we only have 5 args left. This is the Denum, the description, the URL, the supply, max supply. And this is what we expect the user to provide when he's using the CLI commands to navigate our app. We won't look into tests in this workshop. this would just exceed the scope of this workshop. So let's continue with the types. First, when we create new denums, the denum does not have an initial supply. Supply is only updated when tokens are minted and based on the amount that is minted. So we look into message denum.go, types, message denum.go, and remove the supply parameter from new message create denum. New message create denum is just on top, and we want to remove this supply on here. And we also do the same changes that we've done to our new message update denum. So we remove ticker, precision, and supply. Very nice. And before we start implementing the custom logic for creating and updating daemons, we can add some validation into our message denum file. So in here, we look into message create denum function and then into validated basics function. So let's look into message create denum and our validate basic. In here, this is where transactions get checked before they actually make it into the keeper. So in types, we can create checks and validations before transaction actually reach to the keeper, and either have additional checks or logic checks on there. And in here, it's mostly first validation check of if all the inputs are as expected. So we can use the what we recommend you in the tutorial, which are checking for the owner address, for the ticker length to be at least 3 characters long, or maximum 10, and max supply that must be greater than 0. And these are the basic checks that we can start with. Your command line interface would fail if you don't provide the right input for creating a new denum. We can also add a couple of validations to our updating denum, which would be that the owner is correct and also max supply must be greater than. How we get into these SDK errors and error invalid request, we will come there in a second, and we'll show you how to create your own errors. But let's first look into the keeper and actually define the business logic of this module. And this is where we make changes to the database and actually write to the key value store for persistent data. In our keeper method server denum.go file, let's open this. Scroll back to the top. We have our create denum function. And right now, it doesn't contain too much logic. So let's first look into the function and see what it does. So in here, we check if a denum already exists. And if it already exists, we throw an error user. But other than that, we don't have much more validation logic. We know that the format is already right, and users can just create their own denums without much problems. In here, and eventually we define our denum from the input of the user. So you see this message, which has been passed on, for example, from the CLI. And then from there, we get the owner, denum, description, ticker, precision, the URL. We start with a supply of 0, and if it's allowed to change the max supply. And with the function k, which is the keeper, set denum, we write this to our key value store, and that would put it onto the blockchain. Let's also look into our update Denum function, which has a bit more logic into it. So we also look if the Denum exists, and in this case, it should already exist because it has been created before, and we check if that only the owner can actually make changes to this token. Max supply also needs to be set if it's set to true, and as I've explained before, you can only change the max supply once to false, and afterwards it cannot be set to true again, and we make a check for this. And if everything is successful, we update the Denum with the keeper.setDenum file and the described message variables passed in by the user. The ticker precisions be the same as well as the supply, but the max supply can be changed, the URL can be changed, description, Denum, and owner. And if not changed before, can change max supply. Great, this is our logic for creating and updating Denums. We have used functions that we want to make sure that we can use. So we are working with the bank module and with the account module as we defined as dependencies before. And we want to make sure we can use a couple of functions, such as from the auth module, we want to be able to get an account, get a module address, get a module account, and from the bank keeper, we want to be able to send coins in our module and mint coin. So let's use this whole file, update our expected keepers with this. And before we continue, we are now going to create messages and transaction types that will actually execute logic. Before, we might want to save our state again to GitHub. We can see our work as already done with git log. Then we see we have initialized with Starport. We added a token factory module and Denum map. We removed the delete Denum function, and now we have created token factory, create and update logic. And what's missing is now to create messages that lets us work with these logics. So first we need to scaffold two new messages. One is mint and send tokens. So this is for minting new tokens and sending them to a specific address, and update owner. Our mint and send token message requires a Denum, which Denum is going to be minted, an amount, which is going to be minted, and the recipient where the tokens will be minted to. And this eventually, and look into at this in the terminal. We start with scaffold a message, which is called mint and send token, with the parameters a Denum as a string, amount as an integer, recipient as a string. We want this to be part of the token factory module, and the owner is going to be the signer. After we have scaffolded the mint and send tokens message, we can also scaffold the update owner message. It will require a Denum as an input, and a new owner. So this is only 2 parameters. We also want it to be part of the module factory, and the signer will also be the owner of a Denum. And on here you see again, we starthold scaffold message with the name update owner. It has parameters, a Denum as a string, a new owner as a string, and it's going to be connected with the token factory module. Those 2 new messages are now available to Starport, having scaffolded it into the right places. We have files in our keeper such as message server, mint, and send tokens. And this is what we're going to edit in the next step. In here, in the keeper, we'll have this function. And it also, as you've seen before, it will check if a Denum exists. Else it will throw an error. It will check if the issuer of new tokens is actually the owner of this Denum. In here, you will actually find the check that you can only mint as much as the max supply allows. So this is the value found of the supply added with the message amount, so which will be minted. And this is not allowed to be greater than the max supply. On here, this cool function which we've added to the expected keeper before. So we are using the account keeper to get a module address. Each module has its own address that you can access in your module. This address can be used for various purposes. You kind of use this module account to mint new tokens and to send new tokens. But the module accounts can also be used for things such as an escrow. We receive the recipient as a string, but we want to convert this into a proper Cosmos SDK format. And the coins that are going to be minted are specified as SDK.coins. This is described in the ADR I was speaking about in the beginning. So feel free to read the documentation to understand how these coins work. And now we can mint coins and add the new coin, the new minted coins. And we can use the bank keeper function of minting new coins for this. And this will actually make them native coins on our blockchain. After they've been minted, we want to send them from the module account where they have been minted to the recipient address. Only if this is all successful, we can update our Denum with the new minted coins. So on here, you will find the supply line, which is the old supply plus the message amount as new supply, and then we set our new Denum and save it to the keeper. So let's copy this function, or we can copy the whole file, which is message server mint and send token, and this in our code. So we navigate to the keeper. We have message server mint and send tokens, and on here the scaffold, as you see, doesn't have much logic yet. So we will add the all the logic that we've just discussed. Let's also look into the update owner file and make updates to allow changing the owner of a Denum. We will update the appropriate fields of the Denum, add a check for the existence of the Denum, a check for the right owner, and then we can save it in the keeper. So let's look into this. We first find the Denum, we check if it exists. If not, we throw an error. We check if this is the right owner, and then we can update the owner with a new owner. And let's put this into the update owner file in message server update owner. Great. This is a great step. We've created 2 new messages and added the logic for what should be happening as soon as you use such a transaction. Now, we can actually already start to test what we've. Let's run our blockchain with message Starport chain serve. This is now building our protofiles. It's making sure all the Go code is connected with the right protofiles, that everything works as expected. It will install a binary, which will be called the token factory D. That's a daemon that we can work with to query our blockchain. To use all the modules that are available, we can check that all the commands out in a second. Lets us interact with our application. The good thing about Starport Chain Serve is also it makes sure we have everything set for our developer environment. So it will make sure the API is toggled on, and we can do the documentation on port 1317. It will make sure that the gRPC server is queryable, and it will provide a couple of handy functions for us to interact with our blockchain. We'll also create 2 new accounts, which are usually Alice and Bob. You can, when I'm closing all the files, we have a bit more space here. So we can check our config.yaml file. In here, you will find 2 accounts that are typically scaffolded with Starport app, which are Alice and Bob. Feel free to change the native tokens on here as you prefer, and be aware that data needs a minting token. This is most of the time stake in order to keep the blockchain running. So maybe you want to maintain stake, you can delete token or play around with these different parameters. I think, do I have blockchain running somewhere? This is not unlikely. Found it. And now I can trump this again. This time everything has already been built, so it works extremely quick. I use a tool called Jax in order to kind of have a peek into my blockchain and what it's doing. I see here that my chain ID, I'm on the network, which is just Token Factory. Health is good. It's creating new blocks. It's all live. We can see blocks between seconds in our test network. 1 second. This helps with testing, so everything goes into a block very quickly. But this looks good. It's working and creating new blocks. Let's first test out the command to create a new token. I zoom in a bit for you. So this is the command token factory D tx token factory create Denum. We create the Denum use Starport or local blockchain. It's just described as my Denum. The ticker for it is Starport. It has decimals, 6 decimal places, no specific URL. We want the max supply to be 100 million token. And with from Alice, we define that we want Alice for it to be the owner. And with true, this is our max supply. It can be changed. Now it asks me to confirm the transaction. And I can see that the Denum already exists. So let's query and see which Denums already exist on our app. So this seems to have worked. Let's make sure that our blockchain actually starts from a clean slate, because it might be that working on this tutorial, I still have data in my blockchain. So we can start the blockchain with the new state with using the --reset-once flag, and this will make sure we start from block 0 and with no previous data. As you can see, it confirms we reset the app state. And let's try with this same command again. Let's issue again our command, maybe in here where we are able to be bigger. We've talked about all the parameters. We sign this, and voila, this time it works. So it seems I started my blockchain with an old state already. If we use token factory d query token factory list denum, we see our uStarport as defined before, and we see the owner is an address that ends with L5SW, and on here we can see the account created Alice is an account that ends with L5SW. So this is all as expected. Now we can also test updating a Denum. So we want to add a new URL and update the max supply to 2 billion. Let's see how this goes. Let's query our Denum again. And now we can see the URL is a new URL. We have a max supply as 2 billion. So everything worked as expected. Now we want to test out and actually mint some uStarport token, because as we can see, the supply is still 0. And we define an account that it will mint to. So let's have a look into this command. And for the address, I actually keep it this address because this makes it easier in the coming walkthrough, but you can use any of your accounts to add instead of this given Cosmos address here to make your tests. And we now mint and send 1,200 uStarport to this account. Let's see. This went through without errors, and now we want to check actually the balance of this account and see it does have now 1,200 uStarport token. This is super, and we also want to query our Denum, and it also now says 1,200 supply for our new uStarport token. Let's also walk through our token factory update owner message. So we want to update the owner from Alice to this previous test account where I don't have the mnemonic right now, but this is testing anyway, so I can create an owner as I prefer on our token factory and on our new Denum. So let's give this Denum away without any action back because I don't have access to this account. And I now can see this is the new owner of our uStarport, and I can't create and mint any new tokens anymore. So if you use the same command as before with minting and sending 1,200 uStarport token, it shall tell me that I am not the incorrect owner anymore. I cannot mint new tokens. And that's it for your first module. Maybe your first, maybe you have already created some. Feel free to go through all the tutorials on docs.starport.com and to your learning journey. And with completing this workshop and tutorial, you can celebrate that you have created already a token factory module. You've learned how to add a new module, how to work with a keeper and a business logic, how to delete one of the functions from the CRUD operations. So this is how you can do it, also with some of the other functions, depending on which of the CRUD you would like to have available for your module. You have scaffolded a module and 2 messages for the users to interact. So I think this is a great learning experience already. You've touched the most important points which you will need in order to create a new module on the Cosmos SDK. And feel free to also check out the coming chapters after the Token Factory, which are more depth into IBC. And there's a great maybe challenge actually with this Token Factory. If you get integrate some IBC functionality, come back with us, at us with ideas about this. Maybe we can advance the tutorial and workshop, or we can just discuss what's possible with this module. So enjoy learning about the Cosmos SDK. Don't forget to go to hackatom.org, where you find all the details about the Hackatom 6 that we will have launching in actually 1.5 weeks, and register there to win one of the great prizes. Up to 1 million USD are in the prize pools for the Hackatom 6. So make sure to understand how the Cosmos SDK works, go through the tutorials, and then write your module. Until next time, thank you.